If a tunnel is cut at any orientation through Earth, then a ball release from one end will reach the other end in time. Okay, neglect the rotation of the Earth. If I consider a tunnel, okay, dug at any orientation, let us say a tunnel is dug along this orientation. Okay, let the distance over here be equal to s. Okay, its angle with the center. Okay, its angle with the center initially let it be equal to theta. Okay, so let it be equal to theta. Okay, a body is released from this point, let us say this point over here is equal to a, and reaches point b. Okay, now this body will first of all perform SHM. How I will prove it later, but first of all it will perform SHM and it will go on oscillating about the a and b. Okay, that is it will go on oscillating along the distances. Okay, now let me zoom in this part of the tunnel. Okay, that is the a and b part. Okay, if I draw a larger diagram over here, this is a, this is b, the entire angle over here, this is a and this is b over here. Okay, this is point over here is equal to a and the other point over here is equal to d. Okay, so if I consider this angle over here is equal to theta. Okay, the angle made over here is equal to theta, this angle is equal to r, the entire distance over here is equal to s. So this will be equal to, if I consider a point c over here, AC will be equal to, if I take sin theta over here, if I take sin theta, S is equal to AC over here will be equal to, or if I take sin theta, okay, it will be equal to opposite over here is, if this entire length is, if AB is equal to S, then AC will be half of that length, it will be equal to S by 2 upon hypotenuse, the hypotenuse over here is equal to R. So basically let this be equal to sin theta, we will use this part later. Okay, now the acceleration due to gravity, okay, along when it was at A, and let us consider any other point, let us consider it as D. Okay, the acceleration due to gravity will be different at A and D. Now let us find out the variation due to the acceleration due to gravity. Okay, the acceleration due to gravity, since the hole is dug inside the earth, it will be equal to the formula of the depth GD will be equal to G1 minus D divided by R. Okay, 1 minus D divided by R, where D is the depth. Okay, so I can say that, if I say that if in this larger diagram I draw over here, okay, let us say I take an arbitrary point. Okay, let us say I take an arbitrary point where the depth over here is equal to D, the depth is going on varying. Okay, so let me take this as the arbitrary point, let me draw a point over here. Okay, when it makes an angle alpha. Okay, when it makes an angle alpha, if this is equal to R, the side adjacent to the theta will be equal to R cos theta. Okay, so this depth over here, so this depth over here will be equal to, if I consider this depth over here, it will be equal to, this will be equal to R cos theta, and again adjacent to alpha. So this this point AD will be equal to, or I can say OD. Okay, center over here is equal to O, so OD will be equal to R cos theta divided by cos alpha. Okay, divided by cos alpha. Okay, this is basically nothing but, if I extend it along the circumference, this is nothing but R minus D. Okay, the entire length from, let us say this point is E, so OE minus over here ED, OE minus ED will be equal to R cos theta by cos alpha. So R minus D by R, if I rearrange this part, GD will be equal to G R minus D divided by R. So R minus D over here is equal to R cos theta divided by cos alpha. Okay, so GD over here will be equal to G R cos theta divided by cos alpha divided by R. So cos theta and cos alpha will get cancelled out, GD will be equal to G cos theta divided by cos alpha. Okay, this is the acceleration due to gravity. But the acceleration due to gravity always acts in the vertically downward direction or in the direction of the center. Okay, so this acceleration due to gravity that we have obtained will be towards the center. Okay, will be towards the center, but the body is free to rotate only along the direction of the tunnel. Okay, so the component of it, so the component over here will be equal to, since this is alpha, this is G, this is whatever it may be. Okay, this is GD, so the component along this direction will be equal to GD sin alpha. Okay, it will be equal to GD sin alpha. Okay, so let me call this component along the direction of the tunnel be equal to G dash. So G dash will be equal to GD sin alpha. Okay, which is equal to, it will be equal to G cos theta divided by cos alpha into sin alpha. So sin alpha by cos alpha will be equal to tan alpha, so it will be equal to g cos theta into tan alpha. Okay. Now what will happen in this case? Okay, first of all, the body is accelerating till it reaches a certain middle point. Okay, then at exactly perpendicular to it, let us say at the point C, when the body arrives at point C, it is still having velocity in the right hand side direction. It will have maximum velocity along the center, then it will go on continue, then it will continue in the right hand side direction. But now the acceleration, if I mark the acceleration at this point, the acceleration is over here, GD, and its component will be in the left hand side direction. So I can say that the velocity and acceleration are in opposite direction. Okay, then it will reach the point B. Okay, then it will again experience acceleration in the left hand side direction, and it will again go on performing this motion. Okay, so I can say that the acceleration and the velocity or acceleration and the displacement are in opposite direction. Okay, so since we have to find out the time over here, okay, the acceleration and the displacement are in opposite direction. Okay, now first of all, what is tan alpha? Okay, first of all, what is tan alpha? Tan is equal to opposite upon adjacent. If I take this angle as alpha, then, okay, let me mark it with some other color. Okay, this angle over here is equal to alpha. So tan alpha will be this part, okay, which is equal to opposite, okay, upon adjacent over here is equal to r cos theta. Okay, let it move by a small distance x. Okay, let it move by a small distance x with the same acceleration g dash. Okay, so over here I can say that if this distance, okay, that is dc is equal to x. Okay, d is this point. Okay, d over here is this point, and this is over here the c. Okay, dc over here is equal to x. So I can say that g dash will be equal to g cos theta into opposite over here is equal to x divided by adjacent is equal to r cos theta. So basically it is equal to r cos theta. Okay, now this acceleration will be negative. Why negative? When the body is going in the right hand side direction, it experiences acceleration in the left hand side direction, and when the body is going in the left, the acceleration will be experienced in the right. Okay, that is, it will perform simple harmonic motion. Okay, so I can say that cos theta and cos theta will get cancelled out. G dash over here will be equal to g by r into minus x. Now over here I can clearly say that the acceleration is directly proportional to minus x, because g and r are constant. Okay, g is the acceleration due to gravity on the earth, and r is the radius of the earth. So g and x are constant. Okay, so basically it will perform a simple harmonic motion. Okay, that is, it is an SHM. Okay, it is an SHM. Okay, it will perform SHM. Okay, simple harmonic motion. So for simple harmonic motion, the acceleration is given by minus omega square x. So if I compare this and this equation, omega square will come out to be g by r. Okay, omega square will come out to be g by r, or omega will be equal to root g by r. Okay, let this be as it is. Okay, let this be as it is. Now omega is equal to g by r. They have asked in the question, what is the time required to reach from one end to other end. Now what is simple harmonic motion? When a body starts from point A, it goes to point B, and again if it returns to point A, this whole time period, if the whole time period is equal to t, that is to go from A to B and again to return to A, it is equal to time t. So the time required only to go from A to B will be equal to t by 2. Okay, basically it will be equal to t by 2. The time period required to go from A to B will be equal to t by 2. Now t, omega is equal to 2 pi by t, so t will be equal to 2 pi by omega. Okay, 2 pi by omega over here. Okay, so it can be written as 2 pi into root of omega. Okay, root of omega over here will be equal to r divided by g. Okay, if I substitute these values, it will be equal to 2 pi root of, the radius of the earth is 6400 kilometer, which is equal to 64 into 10 to 5, okay, meters. Okay, and the acceleration due to gravity for the time being, I will take it as 10. Okay, for the timing I will take it as 10, so this will be equal to 10 to 4. Okay, when I take the root, it will be equal to 2 pi into 8 into 10 to 2. Okay, so it is equal to 16 or 1600 pi. Okay, basically it will be equal to 1600 pi. This is the time period required. Now this time period is equal to seconds. Okay, now this time period is required in seconds. If you see the options are given in minutes. Okay, the options over here are given in minutes. Okay, so basically I have to, it is equal to 1600 pi. So if I divide this part, it will be equal to, okay, so 2 pi by, and there is also divided by 2. Okay, also divided by 2 over here. So 2 and 2 will again get cancelled out. Okay, So it will be equal to divided by 2. So basically it will be equal to 800 pi. Okay, basically it will be equal to 800 pi. Now this time period is given in, now over here this time period is given in seconds. Okay, if I want it in minutes, I have to divide it by 60. Okay, I have to divide it by 60. So 0 and 0 will get cancelled. It will be equal to 80 pi divided by 6. Okay, 80 pi divided by 6. Okay, if I calculate this value, it will roughly come out to be, it will approximately come out to be 42 minutes. Okay, so the time required is equal to 42 minutes, which is equal to over here, which is equal to option number B, 42.3 minutes.